It is like the worst of winter in reverse as excessive snowmelt poses a rising disaster threat in parts of the country tonight. Along the Mississippi River, flood warnings up from St. Paul to north of St. Louis. In places like Davenport, an agonizing wait for residents.
On November 3rd, 2024, the Mississippi River did something hydrologists believed was functionally impossible. Between Cairo, Illinois, and the Gulf of Mexico, river discharge dropped by 47% in just 72 hours. There was no drought, no large-scale diversion, no measurement error. What engineers would later call systemic hydraulic failure was unfolding in real time. Barges carrying America's food supply ran aground on sandbars that should not exist. Navigation channels vanished. The river that built the nation began to fail as an operating system. The anomaly was unmistakable. October precipitation across the basin measured 4.7 inches above historical averages. More rain was falling, less water was flowing. At the U.S. Army Corps of Engineers Vicksburg District Office, Senior Hydraulic Engineer Robert Chen reviewed discharge data that violated basic conservation principles. His team revalidated the measurements 3 times. Water entering the lower Mississippi system simply was not arriving downstream. The volume loss exceeded the entire annual flow of the Colorado River. At an emergency technical briefing in December 2024, Chen delivered a conclusion few were prepared to hear. This was not a natural decline. It was infrastructure-induced collapse. Every system built to control flooding was now preventing the river from functioning. The question was no longer what went wrong, but whether the continent's primary circulatory system had been fundamentally broken. A river engineered into submission. The Mississippi River is not merely a channel. It is a continental-scale system that has shaped North America for 20 million years. From the Ohio River confluence to the Gulf of Mexico, it drains 40% of the continental United States. Water from 31 states funnels through a single artery. Since 1879, the U.S. Geological Survey has monitored this system with unmatched precision. Flow, sediment, chemistry, temperature, measured continuously at 183 permanent gauging stations. For nearly a century and a half, the data told a consistent story. The Mississippi was predictable. That predictability built an economy. Each year, 800 million tons of cargo move on the river. 60% of U.S. agricultural exports depend on it. The system generates $495 billion annually and supports 1.3 million jobs. Behind this reliability stood the most ambitious hydraulic engineering project in human history. After the catastrophic 1927 flood killed over 500 people and displaced 700,000, Congress authorized the Army Corps of Engineers to end flooding permanently. Over 9 decades, the Corps constructed 3,787 miles of levees, 29 locks and dams, 38 major reservoirs, and massive control structures like the Old River Control Complex, built to prevent the Mississippi from diverting into the Atchafalaya River. The project worked. Floods became manageable. Cities expanded. Agriculture flourished. The river became infrastructure. And that success carried a hidden cost. When the models failed, in August 2024, Dr. Sarah Martinez, chief hydrologist at the Lower Mississippi River Forecast Center, noticed her predictive models breaking down. Discharge at Vicksburg measured 340,000 cubic feet per second, normal for late summer. 7 days later, Baton Rouge recorded just 198,000. 142,000 cubic feet per second had vanished. Sensor error was ruled out. Field teams recalibrated instruments using acoustic Doppler systems. The data held. By September, losses reached 187,000 cubic feet per second. By October, 264,000. Across a 600-mile stretch, the river was hemorrhaging volume. NOAA dispatched a crisis team. What they uncovered challenged every assumption about how the Mississippi now behaves. Beneath the riverbed, agricultural withdrawals were insufficient to explain the loss. Levee seepage was ruled out, but sediment cores taken from the riverbed revealed something unprecedented. The riverbed had lost its stratification. Decades of confined flow, sediment starvation from upstream dams, and aggressive channel erosion had transformed the lower Mississippi's foundation into a high-porosity mass, hydraulically similar to a drain field. Meanwhile, groundwater tables in the Mississippi River Valley alluvial aquifer had dropped an average of 28 feet since 1980. The gradient reversed. The river was no longer fed by groundwater, it was recharging it. Engineers call this induced infiltration. The process was known. The scale was not. The Mississippi had crossed a threshold. It had transitioned from a transport-dominated system to an infiltration-dominated one. We had engineered the river to drain itself. Collapse in plain sight, the ecological impacts arrived first. Fish recruitment failed. Mussel beds suffered 80% mortality. Wetlands dried. The Mississippi flyway compressed, increasing disease and mortality among migratory birds. Then the economy fractured. Navigation depths fell below operable limits. Cargo volumes dropped 53% in Q4 2024. Grain transport costs nearly doubled. 4 major barge operators declared bankruptcy. Ports laid off thousands. Municipal water systems entered crisis mode. Saltwater pushed upriver toward New Orleans intakes. Memphis saw groundwater quality deteriorate as the river drained into depleted aquifers. There was no single disaster, just a slow, systemic unraveling. Engineering meets its limit. The Corps responded with urgency. Reservoir releases, pumping restrictions, dredging, recharge basins. On paper, the plan was sound. In practice, the river responded perversely. More water increased infiltration. Pumping restrictions shifted withdrawals to the river itself. Recharge basins consumed millions in energy, only to return water that immediately disappeared again. By April 2025, discharge at Tarbert Landing hit the lowest level ever recorded. Internal assessments changed tone. Restoration gave way to managed decline. As Dr. Martinez warned publicly, "We are managing a system that no longer responds like a river. Historical behavior no longer applies." The reckoning, no single project was reckless. Each solved an immediate problem. The failure was cumulative, an assumption that a continental-scale system could be modified piecemeal without triggering emergent consequences. Floodplains disconnected, sediment trapped, aquifers drained, beds destabilized. The Mississippi is not drying because nature failed. It is drying because engineering succeeded too well. The river will find a new equilibrium. The only unknowns are how long it will take, and who will absorb the cost of discovering it. Some systems do not recover. They adapt into forms we never intended to create.